Next, I would like to introduce Wynn Everham from Florida Gulf Coast University. He will be talking today about the ecological state of FGCU. Wynn?
They only think they're a state.
Harrison, I think you should have been able to answer more questions. I think that message of have fun, learn something every time is better than anything I'm going to say. Thank you all for being here. I appreciate being able to give a presentation to a nice large crowd. If you have to answer your emails on your phone while I'm talking, I totally understand. I was probably doing it during your talks too earlier in the week. And I want to apologize to Mark Thompson for running over, which I will do, I'm sure. Judy thinks she can pull me away from the podium, but I don't think she's going to be able to. I will be around for the rest of the session until we break up, so if we do not have enough time for questions, I'd be glad to answer during break or during the end of the program. There is a little-known award for Watershed Summits that have to do with the person who has the poster or presentation with the most co-authors. I'm very proud of often winning this. It's a little bit dubious because the award involves buying a beer for Judy for every co-author to make up for all the extra communication that she had to do to be able to keep it going. So, Judy, I hope that you got somebody to give you a ride home today. When we put the abstract together 6 months ago, what were you thinking way back in August? I reached out to colleagues in the departments of biology and marine and ecological sciences who do work on my campus. They sent me stuff. Truth is, I won't do them justice in 20 minutes. I had to cut it down to try to get some kind of a coherent story to it. It doesn't include any of the people from creative writing that use the campus as a way to teach writing. The art people who use the campus as a studio, as a gallery. Our colleagues in the College of Engineering that teach their engineering students with projects right on campus. So you're only going to get a little bit of what we're doing. And I want to touch on some older history of this long list of co-authors for this presentation. Only 5 of them were on campus when we opened. And I really look forward to this moment in time to be able to talk about where we are with the campus. 2 weeks from today will be the 19th anniversary of the signing of the settlement agreement that ended the legal battle about where the university would be developed. And I think it's interesting to step back and think about that. I also think it's interesting to realize that most of my freshmen and sophomores were not alive when that settlement agreement was signed. So let's go back a little bit in time. This is the oldest map I could find of the campus. Apparently the fix was in 139 years ago. Somebody knew where the university started. This is a map that one of my colleagues in CHNEP found up in Tallahassee of the original surveying of Lee County, and she geo-referenced the university and laid it on top of it. I want to focus in a little bit tighter to that, and when I look at this map, I'm just amazed at these people who were walking the landscape 150 years ago with chains, was the way they did measurements, with relatively simplistic transects and with compasses. They didn't have GPS systems. And they laid out our counties, our townships, and incredibly accurately. So I'm not sure with this light how well it's showing up, but this flowway, is called Stewart Slough, accurately represented, and you'll see some pictures of it later. These wetlands right here were accurately placed, and these flowways to the north of campus are important in terms of how they've changed through time. Jump ahead 111 years. This is the aerial photography from 1986, not geo-referenced. I just wrote the boundaries in, kind of estimating them. So they're not exactly right. Some folks, I think that in 1986, someone already knew that this is where we put the university. Some of the features that we see on the landscape are these north-south lines that were Florida rock to the north of the university, driving equipment over the landscape to dig holes to test pits about how big the rock was. The site that ultimately became the university had been zoned for rock mining. It's a little bit harder for you guys to see, but there's also legacies from the 1950s and the 1960s where they had put mosquito control ditches
on the landscape.
And then whenever I show this to my students to help them understand the legacy of the campus, I point out this feature, which is also real hard for you guys to see. It looks remarkably like a runway. So I've started the totally unsubstantiated rumor that drug runners used to bring drugs to campus in the 1980s. That could be true. You know, there were all these great back roads that if you landed a plane in that little short runway right there, you could get it off and get it up to the roads. I also want to make sure that you recognize that already in 1986, that flowway that was to the north of us has been disrupted by I-75 and by the lakes put in the ground by Florida Rock. Jump ahead another 9 years. This is the original planning map. Sorry, you guys can't see it very well, can you? I think the one's actually going to be a little bit better. Kevin Irwin and Associates did the original campus design to how we would fit this university onto this wetland. There's what I thought was an anecdotal story about my first president, Roy McTurnigan, and his wife flying over this particular site. Must have been during the summer. Roy's wife turned to him and said, "Roy, I don't think the good Lord intended a university to be built here." It was probably 1 foot to 1.5 feet deep in water at the time. In this original plan, most of the development for the university happens on 250 acres within this loop road. But there are these outlying areas for development at each of the corners. I also want you to look at this particular road that's going to be leading down to this outlying area later. And then notice right here, this part of jurisdictional wetlands and upland buffers around that. These areas in here are all jurisdictional wetlands. The lines that cut across there are boundaries between either created wetlands or some of the upland buffers. Jump ahead another 10 years, and this is our second revision of our master plan. And I wish I could go back and forth, but I only got 20 minutes. Can you guys catch what some of the changes were? The first is the road that was supposed to go to the south end of campus has moved from here, cutting across Stewart Slough, the piece we could see from the 1875 map, and moved down to the south. Now, why did we move that road down to the south? Because in the 80s, drug runners used to land drugs on campus. They had cut a road across the slough, and truthfully, I thought it made sense in the conversation to not cut a new road through the slough, but to follow this one. And I think that design is pretty good. Box culvert with a raised wildlife crossing underneath that road as it was built. This road is new. In that master plan update, the decision was made if we're going to be putting dorms down here, we needed multiple ways to get on and off campus. And the part that caused me the most concern was that this previously protected land now had some ideas for putting in rec fields around these wetlands, which didn't have the same protection as they did in the 1990s because of the Swank ruling in 2001 or 2002 about jurisdictional wetlands. My concern, one more piece. Now we do have crossings of some of these jurisdictional wetlands in some places through upland buffers, boardwalks. So we started talking about putting boardwalks on campus to limit the amount of on-campus traffic to facilitate more foot traffic on campus, which I think was a good idea. This part that caused me concern was if we did develop this 33 acres that in my mind had previously been conserved lands. I didn't like the process where we decided to do that. I didn't like the potential precedent that that might lead to, and I didn't like the symbolic reality that our 760 acre site would be moved from 53% preserved land to 49% preserved land. This is our current master plan. About to engage in yet another revision. Some of the changes, we added an additional 12 acres of land up here that will be developed to some level. What had been designated as buildings is now a solar array in this area. And I'll come back to this in just a couple of minutes to talk about some of the research that's been done in this area. It's not reflected on the map, but the area right here on campus is or will be become our responsibility as a restored wetland for off-site mitigation for some of the development of Gulf Coast Town Center. So we will end up with an additional 42 acres here. And now, this is the part that really disturbed me. Holy smokes, we lost that 33 acres. So overall, we're now at 814 acres, 414 of which are developed, which just happens to be over 50%. I maybe feel a little bit better about that, but I don't know, sometimes I think maybe I should tree sit down here before we make those changes. But the truth is, I think if we had gone through a better decision-making process for the development of that area on the south end of campus, probably if we had a referendum, I'd lose that fight. I think the students that are now living in those dorms want to have additional recreational facilities near to those dorms. And that my vision of trying to protect what we had originally committed to is not necessarily the vision of everybody that lives on that land now. So, everything up to now has been, what's my time?
9 minutes.
Okay, good. I figured about half of the talk to give you a little bit of retrospective on how the campus has been developed. And now I want to talk about what the faculty and the students have been doing within the campus. So it's a little bit of a shift of gears now. In 1998, we received some money from the National Science Foundation to try to develop analytical capabilities in our laboratories. We thought, we're new. National Science Foundation should just give us $250,000 so that we can buy more equipment. They said, oh no, we won't do that. You have to give us some kind of a good hook. And the good hook we came up with, we called the campus ecosystem model. In the campus ecosystem model, we were trying to sell the idea of integrating our curriculum and our faculty research into the campus, the watershed, and the landscape that we were built into. If we're responsible, the main part of our mission is education. Why not have education within that context? Why not have our students and our faculty in the field collecting real data? If I could read right from that original proposal, the campus ecosystem model provides an explicit context for teaching, learning, and research, thereby connecting students and faculty from different disciplines as their individual efforts converge on common issues. A deliberate linking of the curriculum as it applies to tangible environmental issues within the student's own backyard provides a genuine foundation to the discipline and reinforces basic principles and problem-solving techniques. Sorry, that's the way you got to write for the National Science Foundation. This is particularly beneficial for non-science majors who may have developed fears or misconceptions about science early in their education. So let me give you some examples of how that works. We might take a limnology class, and to be able to teach them concepts of identification of aquatic vegetation, collecting spatial data and transferring that into the maps, they'll be mapping distributions of aquatic vegetation on the campus. One of the things that I think the campus does well is manage some of our stormwater ponds, and I think it provides an educational opportunity for people from the community to come in and see what ponds can look like. Folks like me who originally come from Michigan who might want to see a blue gate glacial lake, and the only way we can get that in South Florida is continued poisoning of the waters to be able to kill everything that's alive in it, should be able to see other sticks. My buddy Dave calls that approach creating lakes that are chemically dependent. You have to keep coming back and poisoning the lake. So I think one of the things that the campus can do is provide a model for some ways of living better on the landscape. We haven't always done it the right way. Some of our lakes, as we've gone through different phases of development, haven't been developed very well. This is on the south end of campus near the dorms. Not particularly good riparian habitat, grass coming right down to the edges. And so we've had opportunities to have students involved in courses come in and do service projects. Probably many of you don't know, I think Sarah Davis is in the back. She runs our university colloquium course. Every single undergraduate is required to take a course that focuses on environmental education. You can't graduate from FGCU without having taken that course. And these are university colloquium students involved in a service learning project to do a better job of building the riparian zone in those ponds, so those ponds can do a better job of sucking up the nutrients that Harrison was talking about. And then Toshi Yurikawa is one of my faculty colleagues who teaches a microbial ecology class. Truthfully, if you guys ask me a question about this, I'm probably not going to be able to answer it. Koji was teaching his students ways to sample for bacteria in the environment, some innovative ways to culture bacteria, and then some microbial ways to figure out genetic relationships by testing RNA. And he sampled ponds on campus and around the campus, and then had the students go through this multivariate analysis and develop these phylogenetic trees. If you were here yesterday morning in the session when people were looking at fish communities in Charlotte Harbor, if you think about the way they talk about fish communities as a measure of the health of the ecosystem or as one potential indicator of restoration success, I could imagine a watershed summit 5 years from now, 10 years from now, where people are using these kinds of techniques to not look at fish communities, but to look at bacterial communities in some of our aquatic systems. Part of what we do on the university is push that envelope, explore different ways, sometimes solve questions that may not have practical applications, and sometimes that kind of pure science ends up having really interesting practical applications to it. And then this slide came from Mark Lucius, one of our graduate students who presented on Monday morning. Mark's work was near the solar array, and you can actually see the solar array in the upper right-hand corner here. Mark was putting in seepage meters into this lake, trying to track the flow between the stormwater pond and subsurface water, and then track the overall flow across the landscape. Really interesting work that all of us who work in stormwater ponds are concerned with. What's the input, what's the outflow below ground from these stormwater ponds? So I'm backing out a little bit. That red part right here is Mark's Lake. We don't yet have a student to work on this, but right here in the middle of this part of the campus is a nicely developed cypress dome. We have about 10 years of hydrologic data from that dome, from the wells, and 5 years ago, 3 new stormwater lakes were put in. So I just see this as a not yet capitalized on opportunity for us to examine that question about when you put a pond in next to a native wetland, what happens to the hydrological cycle in that wetland. So I hope in the future I'll be able to give you some information about that particular project. I also wanted you to see something we did on campus in collaboration with Johnson Engineering, who was our consulting ecologists and engineers for the solar array installation. They were willing to work with faculty and staff so that when they set up the sediment barriers to do the clearing, instead of setting up sediment barriers all the way around the clearing site, they left one end open. They cleared from the west towards that opening to this larger preserve area and allowed wildlife that was displaced from that land clearing, we presume, to move into that preserve area. We can't document exactly how much, but we think and hope it was a successful, different way to do land clearing. We were able to set up live funnel traps inside that sediment barrier all the way around the edge. Just like you were studying snake species, the snakes are displaced by the land clearing, they hit that sediment barrier, they follow the sediment barrier, they go into the trap, and twice a day we walk that, pick up the traps, and relocate those. 132 vertebrates we relocated. Maybe a small thing. But I like the fact that we had this opportunity to take what we often think of as a bad thing, land clearing, and try to figure out the way to clear the land in the most appropriate way. I did talk too long. I wanted to talk a little bit about a 1 hectare plot that we established in 1997 before the campus opened to look at dynamics of forest. It's the first of now 6 plots that we have in Charlotte, Lee, and Collier County. We looked at the distribution of native and exotic trees through those plots. And I do want you to see this quick piece. This wasn't from the plot. This was Mary Kay Cassani's photo records. We had a fire on campus in Memorial Weekend of 2004. And one of our graduate students then focused on the vegetation dynamics following these fires and really documented what most land managers now understand, that the biocontrol agents that are present on our landscape from Melaleuca have really gotten competitive advantage back following fire. So it used to be you light a fire and that was a mechanism by which Melaleuca invaded the landscape. Now you light a fire, kill some of the Melaleuca, the other Melaleuca sprouts back out, biocontrol agents explode, they shoot it back. Brenda Brooks-Salvinson, the graduate student, was able to document ultimately 70% mortality in the Melaleuca slate plots. do one more and then I'll get out of the way. We had an undergraduate who took on as his senior research project to walk about 1 kilometer of the roads on campus 3 days a week for 3 years. Documented over 6,000 events of mortality of organisms that were hit by roads. One of the things that led to, that might be difficult to see in this image, is a recognition of where wildlife was crossing the roads and an installation of these wildlife crossings. And it's caused some conversations on campus between building roads this way without a curb and a swale, or building roads this way with a curb that for small wildlife becomes just like those drift fences that I was talking about, channels them down to these stormwater drains and kills them. I'm thinking that some night you guys are going to read on the news about a group of our students go out on the campus and do some monkey wrenching, probably attack both sides of this with sledgehammers and knock that down to allow that. I know nothing about it. But I do hope that the information that we're finding will change the way we build roads on campus and maybe have a larger impact across the landscape. We still have a lot to do. We need to figure out how to do a fire management plan. We need to think about these transportation issues. We really need to take all this incredible work that's being done by faculty and pull it together into a more cohesive way. If anybody out there is struggling with carrying capacity and preserved lands, I'd like to talk with you about that. I mean that carrying capacity of human interactions. We use some of our weapons on campus for teaching. We probably overuse them. We'd like to figure out ways to be able to deal with that. Oops. So I want to summarize this way. I see you, Kathy. I know. I told you I would be over. All of the work that I showed you, which was only a little piece of what the faculty and students are doing, was accomplished without any external funding. This is just faculty and students engaging in research within their own backyard. Campus is a site of education. Sarah just told me before this that we've graduated probably 15,000 students from that university colloquial course that are now out having hopefully a positive impact on the landscape. And Jessica Ray, who's got a poster over there about the service learning, says that we've documented 1.5 million hours of service learning, not just in environmental issues, but service learning within the greater community. I think that we do a good job of practicing stewardship on our site, but it's really easy for me to think that way because we either make good decisions and it's a model, or we make bad decisions, and in my mind it's an experiment. We can learn from it. I think I'm practicing what John Baird Caldecott encouraged us all to have, which is a philosophy of desperate optimism. We're still focusing on exotics, and the most important exotic that we have on the landscape, which is us. Some of you were here yesterday when we were talking about restoration, and Jim Lapasio said, well, really the only way that we can restore the landscape is to get us all off of it. I don't think that Jim was suggesting that. I think he was reminding us that that's not going to happen. We're not going anywhere. More people are coming, and the university's not going to move. And our job really is to figure out how to make all of that work. I work at a place that's grown too big too fast. Hasn't had enough care for infrastructure. This is a song, it's okay. We haven't done enough in developing the infrastructure. Sometimes my bosses have made bad decisions. Sometimes because they're ignorant. Sometimes because they have a lack of vision. Sometimes because they have different values. Sometimes my science makes a difference. Sometimes it doesn't. I guess we all share that in common. But I really liked what Harrison had to say. You know, the landscape is changing. The people are changing. More and more people are concerned about the things that we're concerned about. On my campus, I have more faculty and students who are asking why and asking why not. And that gives me hope. Thank you. Judy says time for one question, but I can answer more later.
Are you kind of feeling that this calculation I continue to start
I'll answer it slowly. Go ahead, sir.
Again, this is not a criticism, because I think you all have done a great job down there, and you may have asked the same question. Was there a reason why they chose to put the solar field in an area that should not necessarily be developed, instead of putting the solar panels on the buildings where you wouldn't have an energy loss between the transmission point, the initial point where it's absorbed, and the transmission to where you're going to use it?
Of course there was a reason. I'm not sure if I know it. What the students suggested, and I thank you for asking that question, I'll try to do it quick. What the students suggested was a diffuse array that covered all the walkways so that when it was raining they wouldn't get wet. I thought that was brilliant. It probably would have cost more money. What we're being told is that that position for that solar array is temporary, that eventually, I didn't emphasize it, but that part of the campus was always slated for building. So at some point we'll go back into that array, replace what will then be obsolete technology, build buildings underneath it, lift the array up with the better technology then. I fear sometimes it was placed there because you can see it from the road and it's good PR.
Okay, thank you.